Sí, me dijeron que iban a traer el auxiliar, bueno, un adaptador de HDMI a Mac,
Ok.
porque iban a estar tener también su computadora y iban a estar ahí.
¿Renovación médica o quién te lo otorgó?
No sé, creo que el doctor lo iba a conseguir, el doctor. Ya con esto es suficiente.
Ok, ya
A
con
ver,
eso.
deja interno.
¿Y la presentación cómo la vas a dar?
Les voy a decir a sus jefes. Ay, sí. Hay que tener cuidado un poco, ¿no? Por eso le dejé un poco lejos. Deja, mira. Angélica, ya está, mira. Ya nada más que conectes conexión a puro de empezar.
Ok.
Entonces va a ocupar una.
Pero sí está bien, ya te conectaste.
Ok, nada más con esto, perfecto. Entonces de una vez que lo conecte para que yo pueda hacer el cambio allá. Perfecto.
Pues ya que estuvo a ver todo desde aquí, aún así necesité la computadora. Y así de, ay, no sirvió.
Y ya está. Esta que es tipo C. No, pero la aquí también. Porque creo que tengo un C y creo que ese es USB.
No, no, el agárralo.
buenos días, gracias por su presencia. Es un honor poder introducir a nuestro invitado, el doctor Peter Kileen. Les quiero decir que la invitación se logró gracias, y quiero dar el agradecimiento a eso, a un proyecto con ACID, del cual yo soy responsable y que lo compartimos con el doctor Zamora y el doctor Orduña, y le agradecemos a la facultad las facilidades que nos han dado para poder tener la reunión hoy. Déjenme platicarles un minuto acerca del doctor Peter Kileen. Cuando llegué a Harvard a estudiar, se hablaba de un estudiante que había sido un estudiante especial, porque había sido tutor en el curso de psicología experimental. A mí me había tocado a ese año particular ser tutor en ese curso. Y decían, el mejor estudiante, el mejor profesor que ha tenido ese curso era precisamente él. Pasaron algunos años antes de que lo conociera y que efectivamente comprobara que es un extraordinario profesor y presentador de su conocimiento. Pero lo que lo hace todavía un agente más importante, yo digo que de los personajes en el área de análisis experimental es el que más sobresale en este momento, es la amplitud de sus intereses. Nos estamos acostumbrados a pensar que la gente que trabaja en un área trabaja solamente en un problema. Bueno, él ha trabajado casi la totalidad de los problemas que están en análisis experimental de conducta y algunos fuera de ellos. Entonces, déjenme platicarles. Las preguntas que él se hace, dice, ¿cómo aprendemos? ¿Cómo olvidamos? ¿Qué nos motiva? ¿Cómo entendemos las anomalías de motivación, tales como la adicción al tabaco? ¿Cómo mantenemos la atención y por qué es difícil para algunas personas que son diagnosticados con algún problema de hiperactividad mantener esa información? ¿Cómo descontamos los bienes demorados y los bienes probabilísticos, que es de los que nos va a hablar hoy? ¿Qué es la información y cómo la usamos? ¿Qué es la explicación científica y qué es lo que debe de incluir para qué y qué es lo que podemos omitir de ella? ¿Cómo es que entendemos la inferencia científica y cuáles son las mejores técnicas para hacer este trabajo? En general, ¿cómo encontramos una resonancia entre los modelos y los datos y cómo es que afinamos nuestras teorías para amplificar esa resonancia? Muchos de ustedes leen en la primera clase, en el primer curso de AK1, ven un artículo suyo precisamente sobre tipos de explicaciones, y algunos de ustedes también ven en lo que cuando ven asignación de crédito, problemas de causalidad, un fantástico experimento que él hizo sobre detección de causalidad y detección de señales. Entonces, para mí es un placer presentar a ustedes a mi buen amigo Peter Kileen, que nos va a hablar hoy sobre descontando los de su portafolio de deseos. Welcome.
Muchas gracias. Thank you, Arturo. Oftentimes, when you have an esteemed colleague that tells all the good things about you and none of the bad things, it's sometimes embarrassing. But my Spanish is not very good, so I don't know what lies he told about me, but believe them, okay? I think they were good ones. Thank you for coming here on this beautiful morning in this marvelous university in one of the greatest cities of the world. I'm honored to be here, and I am honored to have you come and listen to my talk. In this talk, I'll be telling you some things that have been in the literature. They're mostly my work, that have been in the literature for a while. And I'll be telling you some new things that, with the exception of a practice delivery of this talk yesterday, nobody in the world has heard. So you can say you were here first or almost first in hearing some of these things, which I think are possibly, which I know are important. And I will, if at times I am talking too fast, please do this with your hands, okay? I grew up in New Jersey, and in New Jersey people talk like this. This is the normal speed of talking in New Jersey, you know? And when I took my first job at Arizona State, I realized nobody, just being in the West, nobody was getting it. So I slowly learned to slow down my lectures. I won't talk like that today, but do tell me. On the other hand, if I'm going too slow, go like this, okay? Thank you. Let me fix this other computer. And then we'll begin. Now, already you see you are in exceptional lecture because most people are content with one laptop. This is such an important talk, it requires 2 laptop computers. If there's anything that you seem is important but don't want to interrupt, talk to the person next to you and say, what did he say? I won't mind you're doing. I'd much rather you're whispering to your neighbor, what did he say, than you're not understanding it, okay? So it's first important for me to define my terms. Now, most of you know about desire, might know about portfolio, might not know about discounting. So I'll start with the one that you're expert in. A desire is something you want but don't have. And with the smiles on your faces, I can see what you're thinking about, what your desires are. And I know what they are. I was young once. Okay. But that's an important thing about thinking about what you desire. And you'll see that it's fundamental to the theory that I will present in the last half of the talk. By portfolio, okay, so this is an example of some desires that you might have for food, friendship or love, a cigarette if you're a smoker, drugs if you're an addict, or money if you're anybody, okay? Those, you might not think about them, you know, they're not in your mind perhaps most of the time. And when they're not in your mind, at that point, I'd say, well, maybe you're not in your portfolio. So the portfolio is when you actively have alive these desires. Portfolio is something you keep things in. And I just use that as the name for where you put your desires. As though they were in this genie's lamp, and you could rub it, and the desires would come true for you. Or you could work towards them. And these are the ones we talked about. Now I want to talk about discounting, the next term. You have some sense of it, I think, but it's a very technical sense that it's used here. If you are hungry and have the perfect meal in front of you right now, that's 100% or 1.0 relative value. You know, in terms of food, that's 100%. But the food might be too small. I know restaurants like this. Not around here, but I know some like this. You know, the French restaurants, you pay a lot of money and you get this little thing. It might be too small, it might be too salty. Oh, you might have to wait for it. And it's this last one, temporal discounting, that I'll be talking about pretty much exclusively today. So in temporal discounting, if you had the meal that you ordered in front of you right now, that's 100%. If you had to wait maybe half hour, 40 minutes for it, when you came into the restaurant and you knew that, there we go, and you knew it, you'd say, hey, if I'm going to have to wait that long, I'm only going to pay half as much for that meal. Or if you had to wait over an hour, you might say, I'm only going to pay 25% as much for that meal. That is what we mean by temporal discounting. As things recede into the future, they're of less it's 10 years. And if I gave you $20 in some delay, like 10 years, and asked you what's its value to you now, it might be 20% of that, okay? 40 cents. And the same for $250 or $3,000. But if you look closely at this graph, there's something a little funny about it. One thing that's not funny is all of the curves are the same shape, and they're fit by the same mathematical model. That's good. But if you look at the height of the curves, this one, you can see it easiest if you go to the shortest delay, is only about 65% for the shortest delay. You delay very quickly, small amounts. But over here, it's about 93% or so for the shortest delay. So big amounts, you don't delay as quickly as small amounts. Now that's a key finding that's been in the literature for quite a while. Some of the most active researchers are two guys by the name of Meyerson and Green at Washington University. They generate a lot of good data, and much of what I'm telling you today is based on the data that they have published in the literature. And this is from their work. So they are, I think, the first ones to identify the magnitude effect as such. And you can see it more clearly in this figure from them, with the curves through them from my theory, where you're discounting $10,000 or $1,000, and clearly the squares lie above the circles. You discount large amounts of money more slowly than small amounts of money. So the questions to be asked and answered in the first half of this talk are, what is the shape of the discount function mathematically? And why is there a magnitude effect? And that will lay the groundwork for other questions that I will ask and answer in the last half of the talk. So what is the shape? There are a lot of candidate shapes that are in the literature. The classic one that economists like and would want to work is exponential. It has certain properties that make it very attractive to thinking about money and its growth and decay. So the interest you get on the savings in a bank will grow as an exponential function. This is an exponential decay, but the savings will grow as sort of the upside down of that exponential growth. Very attractive mathematically, and for economists, no data that I know fit that. It's a bad model of human data. There's one that's been introduced by Racklin and Green and Associates, and probably some other people. It's called hyperbolic. I don't know why it's called that. It sort of is a hyperbola. It's a linear function of time. T is the time on the x-axis. Sometimes I use d for that time. And beta is just a multiplier. It could be like 0.1. And so you take that, 1 plus that in the denominator, and you say the value at time t in the future. If I had, let's say, $100, when it gets delayed a certain amount of time, its current value, v sub t, decreases according to that function. And you can see how they compare over here. The exponential function in blue decays more slowly at first and then much more rapidly. So out about 3 or 4 times the time constant, 10, it goes to 0. So 4 times 10 is 40. It's about 0. The hyperbolic decays more slowly, the red one. And that's good, because if we lived our lives by the exponential function, we'd find that our desires for the future are going to decrease in value so quickly, we really can't be prudent, we can't plan well. So something like a hyperbola is a more hopeful discount function. And that works great for rats and pigeons and any other animals. When humans do it, the design of the experiments are different. And that function form approximates the data, but it's not ideal. You have to raise time to a power in exponent. So if s was 1/2, that would be the square root of time, and so forth. If s was 1, it would be back to the hyperbola. And There are two versions that are essentially the same in terms of predicting data, or in terms of covering data. And you can think that t raised to the power s is giving you a psychological time scale, because the psychological time scale is not necessarily the same as the physical time scale. A month from now might be sooner to you than 1/12 of a year. It doesn't have to be linear, and in fact, typically it's not. And so this is justifiable as converting to psychological domain. Now, I want to give you a general treatment. I know that math can be scary to some people. Their eyes glaze over, and I want to talk about that in a minute. But everything here is high school algebra, and you folks wouldn't be in this university if you hadn't taken some basic algebra classes. And so if you don't understand immediately, you know that you can figure it out. So I write the general treatment here just as a way of putting all the cards on the table. And we won't be using all of the cards much today. We'll mostly be using the first couple. So I'm calling utility. Utility is how good a thing makes you feel. Its value to you. If you like a particular kind of cheese, it might have a high value. If you hate it, 0 value. Of a good, G, at some amount, some delay, and some probability. So what I'm going to argue, this is so obvious, it's trite, there's no truth in it, it's just a way of framing the variables I want to talk about. F tells me how these combine, and the small f's tells me the utility of each of these pieces of the good. So what I'm saying here is that the value of the good to you is some combination, maybe addition, maybe multiplication, of the utility of the good and the delay. If that's clear, nod your heads. Okay, I've got more than half nodding, I can go on. If I do that and you're nodding like this, I'll worry. So for example, the utility of a good of amount A delayed by d seconds is some function of the utilities. In all of the standard models, that function is multiplication. So in the example we just gave, the exponential discount, the f of A is the thing itself. It's just an amount. It's not transformed linear. And the f of d is the exponential term that multiplies it. Standard discounting model, the one that doesn't work very well. So there's another way to do it, and there's not hardly any people that do it this way, except this strange guy 10, 15 years ago. And he said, no, let's try adding them. Now, addition's got some problems, but it's got some potential. So let's see how this works. Utility of the good is some function of the amount times some utility function of the delay. And I have to ascertain what are those functions. Well, here are some potential functions. There's a linear function, which says, and that's what classic economics says, expected value model, that the utility of something to you, if you double the amount, your happiness doubles. You triple the amount, your happiness triples. Simple, basic model that's wrong. Could be square root function, that your utility goes up according to this curve, your happiness a little more slowly than the amount itself. And the most extreme is logarithmic. Now, all power functions, whatever this exponent is, fall between this line and this line. So the power functions covers the bases. So I'm going to do an experiment. Okay, let's suppose MLO recognized the importance of you in the classes in psychology that you're taking, and he said, this is the future of Mexico. I'm going to give them all, let's say, we'll start with 1,000 pesos, okay? some nice meals out of that. Makes you happy. Think how happy it makes you. Now, how much would it take to make you twice as happy? Think about how many additional pesos. Okay. Normally I would ask for estimates, but we did this experiment yesterday, and I'm talking slowly, so I won't take time to do it again today. I'll use yesterday's data. There were some low numbers, some high numbers, but most of them were about 3,000 additional pesos, which might be close to your value. So in the example I picked, the numbers are off a bit, but it was 20,000 pesos, I think. And the question is, at twice that, what would the utility be? And in that case, sorry for the confusion of the values, in that case, twice the happiness of 10 would be 20, and if it was linear, you'd say you just need another 20, but they needed more than that, just like you needed more than twice. And so you can extrapolate this and find that some power function, whoops, I didn't mean to do that, some power function that goes through that crossing point will give you your utility function. Now that's a baby experiment. Much better ones are done. You get the sense that it takes more than proportional to make you more than proportional. To even make you proportionately happy takes more than the proportional amount, which means you have a concave utility function, which in most cases most people do. And so, actually I thought I had it. Yes, okay. Here are some data that were published from Europe about you find some money on the ground that is yours to keep, a certain number of euros. How pleasant is that? And the answer was this curve that you see through these circles. And so, once again, it's a concave utility function, and a power function fits it very well, in particular with an exponent not 1/2, but about 1/4, 0.28. So yes, we know, we've got some confidence that the utility function for gains is a power function of amount with a constant in there to cancel out the constants by which it's measured, pesos or dollars or candy bars, and K has the inverse dimension. So next question is, what is the utility function on delay? Well, utility of delay, that's a strange concept, you know, but we'll work that out directly. So here's one future function that was reported in the literature of the psychological distance to sometime in the future by these months. And they did a magnitude estimation task, if you've known what that is. Once again, it wasn't linear. And I put these in for other theoretical reasons, but the main curve that goes through the data beautifully is, you guessed it, a power function, here with an exponent of 0.25. There are other data like this, also embedded in my model. It always works to assume power functions on both variables. So we're moving ahead now, and I'm going slow on the basics to make sure you understand them, because the basic model is powerful, and if you just do the equations without knowing what it's about, it takes all the fun and value out of it. But I think you're having a sense of it now. So I'm arguing that the utility of an amount is a power function of the amount. Utility of a delay is a power function of the delay. But since delays are bad, oops, I didn't mean to do that. Okay, since delays are bad, there's a negative sign in front of it. So the matching experiment's a very nice one. The way the matching experiment works is they will come to students or subjects and say, I'm going to give you $1,000 in a year. How much do I have to give you now to make you just indifferent between the two? So you match essentially you're matching the utility of the immediate with the utility of the delay. And they try different numbers until they've got it equal. It's a really nice experiment because it lets you balance things. Now we know on the right-hand side, the utility of a good is the sum of the amount, which is a power function, and a sum, a negative of the delay. The amount minus power function of the delay. And so if the delay is 0, then something delayed by 0 is the same value as the thing now, obviously. So what we could do is we can replace both of these utility functions with these power functions. And now what we're looking at is balancing the utility of the immediate with the utility of the delay. But we don't measure utility. And in this nice matching design, you don't have to measure utility because you can take and divide everything by k and call the ratio. When you do that, the multiplier of this becomes 1, and of this becomes the ratio of the two k's. It don't matter. Lambda just is a combination of these two k's. And then take the pardon for the noise. Take the alpha root of each side. So a to the alpha raised to the 1 over alpha is just a. You do that to the right side. Now that is the fundamental, most important model of the talk, because on this everything else is constructed. And all it is an addition of two utilities and then solving the dollar value, a sub naught, for one of them. Oftentimes, what people report is not a sub 0, which you've just seen us derive, but the relative value. So if you take 35 pesos now rather than 105 years, the relative value is 35 over 100. So this would be the 100. That would be, we would discover in our experiments 35. We take the ratio and we get 0.35. And how does the model do it? It divides each side by a sub d. And when you do that, you get this. Now this is the second most important equation, and it's immediately derived from the first most important. And this gives us the answer of why there is a magnitude effect, and it will give us the answer for why there's a commodity effect, and why there's a person effect, and why the steepness of delay discount gradients varies from them. So if you have pretty much understood everything to this point, you understand the key to everything I'm going to be saying in a few minutes. So, the magnitude effect. Here are some data, again from the University of from Washington University laboratories, Green, Meyerson, and McFadden, their student. And they have 4 discount functions for different amounts. And there is a magnitude effect. The curves for these data are drawn by the fundamental equation here, with a value for alpha of 0.1, which is very typical, a value for beta of 0.6, and it ranges around 0.5, 0.6 is good. And lambda, the rate of decay, the apparent rate of decay, is 0.1, the ratio of those two coefficients. That gives all of these curves with those parameters. And then we can do the derivative relative value, and it draws these curves. I didn't put the data here, it was just too noisy, but it does just as well with relative data, of course. Now, the magnitude effect comes about because this number is in the denominator. It might be easier to see in the prior slide. By getting the relative amount, we've put the utility of the amount in the denominator over here. Maybe you can guess what's going to happen. If I increase the amount, then the utility will increase, not proportionally, because alpha is only 0.1, but it'll increase. And this measures delay, multiplies delay, and constitutes the rate of decay of the function. So as the amount increases, the slope seems to decrease. And when measured on graph paper, it does decrease. Lambda doesn't change, but because this is in the denominator, It says the larger the magnitude, the slower the delay. Now, I could fit the data with a different model, and I could change the parameters for each of the curves. That's what people do. The strength of this is this prediction is forced by the theory without any change in parameters. So that's nice. Oftentimes we say predict in science and psychology when we merely mean account for. That is, you can do curve fitting. We've gotten used to calling that predict, but it's not really. This is a prediction. It says positive magnitude has to happen. And it does, as we saw. And it does, as we saw. So, what is the shape of the discount function? Shape of the relative discount function is that. Why is there a magnitude effect? You know. Because when you look at it happens too in the absolute, but it's harder to see as it goes up and down. The relative lines things up, and it makes it clear why there's a magnitude effect, because we're dividing by a function of the magnitude. So, those are important, and if that's all I said today, you probably learned something well worth the time you spent in this lecture, or will spend in the lecture. But it gets juicier as we go on. Okay? So there, of the three effects to be explained, one is the commodity effect. By commodity, I mean, what is the good that you desire? Could be pizza, could be a girlfriend or boyfriend, could be anything. I don't mean to think of people as commodity, but it could be anything you desire. Now, here's a nice experiment outside of the Washington University, UC San Diego, by Charlton, the student of Ed Fantino. They compared delay discounting for these were students, the students' food of choice, and you can guess what their food of choice was. Okay. Or for, at the time people weren't streaming, and so the CDs or DVDs or CDs that they wanted, you'd get so many of those, and that's what was discounted, or money. Now I've changed the axis on this because when you do a linear x-axis, everything tends to get shoved up into the left part of the graph. So I wanted to stretch it out. So there's a logarithmic transform there. It doesn't change anything except the presentation of the data. It makes it clear what's happening at short delays. As you can see, the discount function for money is the highest, the triangle is the shallowest. The discount function for music, or maybe they had podcasts on them, I don't know, but music is intermediate, and for pizza is the fastest discount. This is found time and again. These are some of the cleaner data, but it's very reliable finding, although nobody predicts why the curves fall out that way. But you will be able to at the end of this lecture. But to understand why that happens, there's another key term, and that's decreasing marginal utility. How many people here have heard of this? Well, I won't ask how many people understand it then, because I can compute. It's a very important concept in economics and in life. If you look at any utility function that's concave, and for amount, most of them are concave. I don't know of any that are linear. Some might be logarithmic. And here, let's say we've got slices of pizza, because it's easier to think about. You get one slice of pizza when you're hungry, and that might give you a pleasantness of 28 or so, the first data point, first circle. The second slice is good too, not quite as good. It brings you up, to 35. And it keeps going like that, with each new slice of pizza adding a little bit less to your total pleasure. That is diminishing marginal utility. That with additional amounts, the additional pleasantness keeps growing, but less and less and less, and that gives the concave function. Okay? Yeah, and if you do get it, I nod your head, and so thank you. If if no heads are nodding, I'll worry and I'll go back and go slower. So I'm Irish, so I can tell you this joke. This Irishman finds this genie. Oh, thank you. Somebody knew that I was a wanderer. They put a tag on, if this man is found, please send to UNAM. So this genie appears to this Irishman while he's walking along the beach. And this genie's gin or whatever, and he rubs it, and a genie comes out and says, "Oh, dear sir, thank you for liberating me. I shall give you 2 wishes, anything you want." And he says, "Ah, bigari, that is wonderful of you. Oh, what a generous thing to do. Oh, you know what I'd really like, I'm a little ashamed to say? I would like a mug of beer that is always full. No matter how much I drink and put it down, it comes out. My favorite beer." He's got it. It's, oh, that is good. And then she says, "Well, sir, you have another wish. What will it be?" "I'll have another one of those." So that joke tells the story of diminishing marginal utility. Once you got one of those, especially whether or not it fills up, I find for me the first taste of a beer is the very best. The rest are good. But the second beer, maybe for sociality, maybe it tastes good, but beyond that, not much at all. So it doesn't have to be a refilling stein or mug. It just has to be anything. First slice of pizza is great, first bite of pizza is great, and it diminishes. That's diminishing marginal utility. If you have a concave utility function, which you always do, then you've got decreasing marginal utility. This doesn't make boom noises, so I'll keep it. Also, I feel like a crooner up here. So, the solution to the commodity effect is in our hands, and it's in front of you. Some commodities increase, all commodities increase with amount. There are exceptions, but let's not go there. But some increase more than another. Your appetite for money is not going to be satisfied with $2. The third dollar is going to have very small diminishing utility. It will diminish, but for pizza might go much faster. That's the key for action, and let me play it out. So I give you, did anybody notice the subtitle of my talk above the first title in small print? Somebody did. So some of you were not scanning the slide as much as you should have. You should always scan your environment. The small subtitle said 100 pizzas. Now, if I were to give you one pizza, you'd like it. If I were to give you 100 pizzas, no way. If I were to give you 100 tunes of music, well, you might like that, as long as they're different songs. It can't be like, I like that song, I'll take another one of it. But as long as they're different songs, there's more diversity in music than there is in pizzas. I mean, you can change the toppings in pizza, but a pizza is a pizza is a pizza. And that's not true for music. It keeps surprising us how good music can evolve to be. And so there's more diversity in music. But within each, there are limits. The music is just music. You can't exchange those songs for a new pair of jeans or for a dinner. There's limited variability within that range. Money, however, you can buy some pizzas, you can buy some music, you can buy lots of things. And so as you increase the amount of pizzas, the psychological value, the amount raised to the alpha power, is going to plateau pretty quick. So this denominator is not going to keep increasing. It's going to flatten out at maximum, to go to maximum, decreasing this fraction and giving you a steep discount gradient. Money has got, its utility function lies above that of music and pizza. The marginal, therefore, the marginal decrease in money is much less. You know, you're not going to get satiated if they give you 10,000 pesos. You'll say, more, please. And so all of these effects play out in how quickly you satiate on something. And the second thing is the liquidity, which I'll talk about in a minute. Not on this slide, apparently. So the next important point, so you've got that about why, okay, first two facts, the shape of the discount function and why the magnitude effect. The second thing, why the commodity effect. The commodity effect occurs because utility of amount is in the denominator and you get less utility out of more of one thing like pizzas than of money. And so that changes the shape of the discount function. I don't think anybody's predicted that before. But it's an obvious concomitant of the basic model and diminishing marginal utility. Now, the next point is you've got this portfolio of desires or of goods. And let's suppose you've got the current portfolio, and then I can say, I want you to create a new one, and I'm going to give you 10,000 pesos. What are you going to put in it? Well, it's obvious if all you put in it is pizza, its utility is going to be limited. So the best way to optimize your portfolio of goods, or to think about it of desires for those goods, the best way is to have a diverse portfolio. Some beer, some pizza, some dinner, some movies, some music, some dates, on and on. So for the same amount of money put into a portfolio, the best way to optimize its utility is to have a diverse portfolio. Lots of stuff in it. And the reason for that, which should be sort of obvious to you now, is that if you have a lot of curves like these two, say for different items, different commodities, and you have a bunch of them, what you're going to want to do is pick the particular item that has the highest potential for increasing your happiness. This one does. But two of these only give you this much, and well, one of those not so good, but three of these only gives you this much, and you'd be much better off for the marginal utility to spend it on another item, and so on, until you've got enough items in there, all at the beginning part of their utility function, where they give you the most value, the most benefit. And so what you want is a diverse portfolio, and for the reason money is special, it's very hard to trade pizzas for something else. Maybe in a bar you could say, hey Joe, I got 2 slices of pizza and you got 2 beers, want to trade? But you can't do that in general. And so liquidity means how easily you can trade what you've got for something else. And what's the most liquid of all the commodities we've been talking about? Money. Yes. And that's why it's the highest. It's really a little different than the other commodities because of its huge liquidity. Some of these other things has some liquidity. Money can be used to get you anything you want, pretty much. Maybe not love, but they say. So I'm being redundant here with the slide. Did I want to say anything else about it? No, not really. Okay, so we know about the magnitude effect. We know about the commodity effect. We know why a more liquid good, which you can spend to optimize your portfolio, it's got more utility and therefore slower discount rate than other goods. That's a lot of stuff right there. Personal state's another one that's quite important. An important meta-analysis indicated that steep discount functions are robustly associated with severity and quantity and frequency of addictive behaviors. The magnitude of this relation did not significantly differ across the types of addictive behavior examined, offering further support for steep delayed discounting as a transdiagnostic process in addition. By transdiagnostic, of course, what they mean is different kinds of addictions give you the same steepening of the discount function. Now that's curious. And also other conditions like depression, other mental health issues cause steeper discount functions. Now why should that be? Let's take somebody that has a cocaine addiction or a heroin addiction. Let's say heroin, because I want to give you a quote from Burroughs, who's a heroin addict and an author. But let's suppose you're a heavy heroin or meth or cocaine addict. What's in your portfolio of desires? Absolutely, drug of choice. You'll spend all your money on it because they tend to be expensive. What does that do to your portfolio of desires? You're no longer able to distribute the money you get to optimize because you're addicted, your brain has changed, and all you want is the drug of choice, even though it's going to suffer this discounted marginal utility. If you were smart, you'd use it for other things. Some drug addicts give up what's most important to them, family and career and future. Not that they don't value them, but they need, because wanting has changed to needing in Berridge's terms, they need that drug of choice. And so they suffer substantial decreasing marginal utility because they can't diversify. It's not in them to diversify. And their curves are steeper. Here's some evidence of that. Here, Madden and Associates out of Utah that control delay discounting for relative value. And the value could be about dollars, or it could be the amount of heroin these dollars would give you. Well, this was the steepest function, the heroin. I have no way, I don't predict that. I don't know why that would be. But I can make a story about it post hoc, but I won't do that here. The curious thing is this. Why should heroin users discount money more steeply? And it's for the reason we just said, because it's all going to go into one place, pretty much. So we have a transdiagnostic process. All addicts do it. Nobody has an explanation for why addicts are like that, across all kinds of addictions, except you do now. There are other it's redundant, but there we are. Suffering increased. And there's two other things to say before we get to that slide. Well, how about this other class of people? There are some people who are not addicts, but have very steep discounting functions. And among them are people that are depressed, are people that are impoverished all their lives, and other classes of people. Anybody on the DSM, Diagnostic and Statistical Manual, will have steeper discount functions. Now, why does anybody have an idea from all you've learned today why depressed people might have a steeper discount function? All of these wonderful people here, somebody must. How do you go about what's one of my key tools in thinking about these things? It's in front of you. What's in front of you? Well, I'm going to stay here till somebody says something. Question 1, what's in front of you? Hmm? Yes. Thank you. Somebody has to talk. Portfolio desires. So that's the tool we use. So a depressed person, what's in his or her portfolio of desires? Not many options. No, I don't feel like that. I don't want to go out and eat with you. No, I don't want to go outside. Life really sucks. You know, I don't want to do these things. A very small portfolio of desires. There is one operation that makes the discount function shallower, not steeper. There's two, I think. There's probably several, but the one that jumps out and has been validated in meta-analyses is episodic future thinking. And I know I'm running over, but I'll try to wind up quickly, but if you have to leave, do so. Episodic future thinking is, I might say, Dr. Bouzas, I'm going to give you 10,000 pesos in a year. What are you going to spend it on? And he'll tell me about all the things that professors spend their 10,000 pesos on. And then I'll give him this delayed discounting. Okay, now I can point this at people that don't answer or give me the wrong answer. Ah! So he's going to tell me all the things that are in his portfolio of desires. And then I'm going to do a delayed discounting experiment with him. And he'll have a more shallow discount function than he would otherwise. Why is that? Because what was a latent portfolio of desires, he doesn't go around thinking all the time about what he wants in the future. It's been made manifest by those instructions, made it active by those instructions. Now we know that delayed discounting, the steepness of the function, also predicts success in the world with more impulsive people, steeper discount functions not doing so well as those with flatter. And it might well be the case that since we know how to make the discount functions more shallow, it's by episodic future thinking. That might be a really good innovation in general. In fact, for young people, and maybe even older people, it's very reasonable to say, what do you want? What do you want in life? What do you want in this relationship? What are your goals? Now these are nice things to do, but maybe here's one of the reasons they're nice things to do. They keep your eye on the possibilities of your life. And just by doing that, they may be the causal agents in getting greater self-control over the issues in your life, flatter discount functions. So this notion of asking people. Okay, so this is just about the last slide to remind us that all the magic is done by that equation or its parent. And this is an equation I won't have time for, but it tells how if you divide up the 1,000 pesos into n different entities, the number of things in your portfolio, mathematically you will be increasing the utility of the portfolio. You don't have, it's a trivial model, but it's not worth going into right now because time is out, but it's calculable. So that is the story about discounting your portfolio of desires. And the take-home lesson is that in life, first, scientifically, you might be able to get a lot of results out of small things if you think and introduce new concepts from outside traditional literature. But more importantly in life is that your portfolio of desires is really important for you. And deciding what to put in it, what's going to be good for you in the future, isn't just nice thinking. It's more than that. And so there are a couple of take-home messages. Maybe the most important one is have a cultured and broad and diverse portfolio of things you want for yourself and those around you. And I suspect it's going to make life a little better given the context, whatever the context you're in. It's going to make life better than anything else. So thank thank you for being here today and paying attention and nodding your heads once in a while. And I didn't see anybody nodding them like that, so I'm happy. Thank you. Thank you very much, ladies and gentlemen. Thank you very much. If there's, most people have to go now and should go. If there's anyone that wants to hang around and ask questions for a little bit, I'm happy to accept them. But otherwise, hasta luego. Please.
Your model could also explain why addiction makes people sad, because actually it's a reduction of what gives you pleasure.
Great. I didn't think of that. And you did. You heard it. What's your name?
Fernando.
Fernando. That's a nice point, Fernando. I might use it. I might give you a footnote. Just email me and I'll have your last name. Just email me and I'll have your last name. Fernando, my email is my last name at ASU, Arizona State University.edu.
Okay.
Thank you. Nice. Any other points or questions? Yes.
Hello. I wonder whether in the case of the function for money, whether with different people it has a different shape. We've heard of people who are involved in finance, for example, sometimes really prioritize short-term movements of their money over long-term investments, perhaps because they're engaging usually with this with higher amounts of money, so that they value it differently. I don't know, but that was a question.
That's a good point. I've not tried to, I've not thought about this model with respect to stock trading, let's say, or financial arrangements. It might be relevant. I'd have to think about that, but certainly short-term gains, you know, everybody says if you put your money in a stock exchange that traces the market, you'll do well in the long run. Just leave it alone. Don't worry about what's happening unless you're getting old and you can't wait. But a lot of other people are day traders. And I think that's a kind of addiction where moving money around and getting a little bit better, it plays a role in it, but it also might be something to do with this model. I don't know, but I'll play with the idea. Thank you. Oh, you will get your exercise.
Well, first of all, thank you for the talk. It was awesome. I was thinking, and also adding what Fernando was highlighting, I was thinking about the optimal grip. This is the theory about affordances and optimal grip to the environment. So it's closely related. So to have like a diversity of affordances, possibilities of action, it's closely related to well-being. So the context is also very important in this theory. So maybe you have a lot of desires and a lot of affordances, possibilities, but in which context are you situated on? So maybe money is kind of very, very relevant because it affords us like a huge amount of possibilities of actions. But if we are in a forest, so the value, the meaning of money totally changes.
May I interrupt? Yes. Yes. Context is everything. On a desert island, there's not much chance of a big portfolio. If you're a poor kid to poor parents with poor prospects, there's not much chance of that. But just changing the environment, and I love coming to university campuses because the environment's usually quite diverse. I see interesting buildings and open spaces, and I see interested students running around, some worried, some happy, and the diversity pleases me. And so I think it's very closely associated. I've not tried to map that. I know one of the operations that flattens the delay gradient is exposure to forest scenes. Amy Odom and others have done that. And landscape architects know that too. So that's why they say if you're feeling depressed, although you're not going to be able to get a pizza in a forest, what you're going to see is a huge diversity of land shapes and forms and green things. And that can help. So context is everything. It constrains the portfolio. And remember I said the portfolio is what is currently active, and the context you're in is going to condition what portfolio is currently active. And so yes, it's all situated. And your point about the environment's diversity is very well taken. Thank you.
Thank you.
Okay, so I have two questions. The first one is, with how much precision can we predict the discount function of a given person, and what variables are the most important to do so? And the second one is, what do you think are the most interesting application of this knowledge?
Wow, those are big questions. I'll disappoint you in the first one. Other than for classes of people, such as children versus mature versus old, such as we were talking about depressed versus non-depressed, for classes like that, you can predict greater or lesser steepness of discount functions. For people who have had activities, such as episodic future thinking, that might broaden their portfolios, we could say that group of individuals are probably going to have shallower discount functions than others. I think all of the discount functions are going to follow that basic equation. What your particular parameters for it are, I cannot predict. I don't know that anybody could. Maybe if I did other experiments with you, or on you, I could say, wow, people like this, do that. So I can't, prediction is very hard, as Yogi Bear said. Prediction is very hard, especially about the future. And a lot of things we call prediction in science are not prediction. Real prediction is rare in science. But having an account that covers the data well and makes sense compared to other things is what most science progress is. And then the second one was, say again?
What do you think are the most interesting applications of these findings?
Well, I don't know. So you're asking me to expand my portfolio of applications here. That's a very leading question, but it's a great one. We know that a lot of the delayed discounting work gets sold to the government, National Institutes of Mental Health, by saying people who are depressed have steep gradients, so let's try and do operations that bring their gradients up, and it might help them be not so depressed or whatever. I don't know if that's going to work, but that's how they get their funding to run their experiments. And they're generating good data, so I'm not unhappy about that. If they were right about that, that would be hugely important. I think one of the more important applications is that for parents, they should always help their kids keep in mind the possibilities of themselves and the world around them, without expectations that are going to be impossible to achieve. Nonetheless, set goals for them, and that might make them more energetic in their life trying to achieve them. Now, that doesn't come out of my equations. It's just a hypothesis that it might be useful. Other ways, I think you can, this class has learned enough about this, and you have from your questions and suggestions, that you could probably figure out hypothetical applications that might or might not work, and that would be great. That could be a thesis for you. Let me know about it. I'll steal the ideas and publish them as my own. It's good. No, I wouldn't do that. So that's a good question. I think it just takes some creativity on your part and maybe on mine to get there.
Okay, thank you.
Thank you. Oh no. Trouble's coming.
Okay, I have a question. you say that it's important to diversify our portfolio, that will make us more happy. But what happened, I think, like in the special case of anxious people, most of them...
Are you talking about me?
No. But they maybe have a lot of options in their portfolio. It's very diverse, but maybe they are not as happy as a normal person. Maybe because, I don't know, like they imagine a lot of fears. But
I mean, that's, potential application, talking about that too. Old people, not myself, by the way, old people tend to lose aspects of their being that compromises having a diverse portfolio. They don't hear so well oftentimes, and so even with hearing aids, music isn't as rich as it was. They don't taste or smell so well oftentimes, so food loses some of its appeal. They need glasses. They can't go out and run a marathon anymore. Most old people can't. They can do some mild exercise, but they can't take the joy in sports of a hard racquetball game or something quite as much as they used to. Maybe pickleball or something like that. But their options are getting more limited. And I think that's part of the reason for depression in some seniors. And I think that what that means is that relatives of them have to try and keep opening them up to the possibilities. Maybe instead of growing all their vegetables, a nice little flower garden that they can tend, and so forth. Opening up the possibilities within their métier will optimize what they can have of pleasure in life, and it might be a huge step forward.
okay, and another question related to the first one is that, I don't know, like maybe exists an approximate number that is like the optimate number to have in your portfolio to size, and that it will differ in different populations, like.
I think there are. I think the answer to those questions are yes and yes. I think there's an optimal size. It's not in the equations that I gave you, because the last equation I showed you, here, for those that know calculus, if you take, this is the increase in the utility of the portfolio from the money that MLO gave you. And that's the prediction of the simple model, and you can take n outside the parenthesis, so you have n raised to some power less than 1. And then if you take the derivative of the portfolio with respect to n, it's going to keep increasing. So the theory says, break it up into an infinite number of pieces. Now, you can't do that, of course. You can only break money up into a centavo, perhaps. But there are other things that are a more serious impediment to having a large portfolio. Let's suppose amongst the items in your portfolio, you want a dog. Well, this equation might say, well, 1/4 of a dog plus blah, blah, plus, plus, blah. Now, a quarter of a dog is no pleasure at all, I don't think, depending on what part it is, for sure. And so there are some things, machines and people, that have a unit size that you can't get below. And so that's one big limit. Another big limit is short-term memory. How do you keep it all in there? And maybe that's why 6 or 7 is the optimal number for humans. Well, there are other limits on the number of things you can get. Utility functions that involve objects that have to be bought in large parts, like bicycles or automobiles, are called Markowitz utility functions. And they're no longer simply concave. They start out flat until you get a whole one of something, a whole dog, let's say. So parts of a dog are not worth much until they're all put together into a whole dog, and then it jumps up a bit. So that's another. So I think those are the reasons why there's an optimal size, and you could build it into this, but mathematically, but it's not worth doing. Oh, yeah, and you asked about populations, and I think there are differences there, but it's only speculation.
Hello. First of all, thank you for the lovely lecture. I think I learned a lot of new things.
Wonderful.
I was wondering if you're aware if there are any cultural differences in the general discounting model, because I'm, for example, from Germany, And I've noticed that I'm way more impatient than most Mexicans I've met. So I think that I would discount things faster, but
Yeah.
I don't know if that makes sense or if there's any evidence or things like that.
It makes a lot of sense. There's evidence. I don't know how general it is, and I don't remember exactly what it is, but the Washington University group, Meyerson and Green and students, have done these kinds of experiments in different cultures, and they do get systematic differences in discount rates. Now, I forgot what they are, but impatience is a different thing. Sometimes people call steep discounting functions a mark of impatience, impetuosity, character traits. And I don't think it's exactly that. I think it's that people value different goods differently, and it goes into the equations as it does. It's easy to think that you're a very steep discounter depending on how much you value the good in question, according to my model, not according to others. And so if some cultures don't value a particular thing as much as another culture, which is understandable, which is true, then it's going to look like they have different temporal discounting, but it's really, it could be the same lambda, it could be the same rate of time impatience, and it's just that the amounts differ, that the utility of the amounts differ between people. And so that's a way of misinterpreting differences in steepness of delay gradients as impatience or patience, when it's really a function of evaluation of the amount. And so a lot of things that are hastily concluded, like ADHD kids must be much more impatient because they do things more quickly and they can't, well, yeah, maybe they don't value the same things you do. Maybe it's not the delay gradient. So a lot of things having to do with delay have to be rethought in light of these insights. Then, or what does one say? Entschuldigung? No. Yeah, in German. Okay. Okay, thank you.
I have a question.
Two
How-
questions?
Yeah. Well, last one was a comment, actually.
It was an insight.
Yeah. But how might, because you analyzed how your model related to access to new commodities, right?
Yes.
How might these relate to negative stimuli instead of access to new things or beautiful things or useful things, escaping negative things?
We don't have a chalkboard here, but great question. I have a model hypothetical answer, okay? Set up that basic equation. Utility of the immediate harm or loss equals disutility of the delayed plus the time factor. So you got a minus utility. Let's say I have to pay $1,000 in student debt at the end of the semester, or I could pay X dollars now instead. So that's a scenario where you could do the matching experiment with debt or harmful things. If you set up the equation, you've got minus utility now equals minus utility in the future plus the delay, because now delay is working in your favor. If I don't have to pay my student debt for 5 years or 10 years or 100 years, it's better. So now delay is a positive good. So you've got minus utility of amount, minus utility of delayed amount, plus utility of time. Multiply through by -1, it gives you the old equation again.
So in this case, that is good.
So in this case, you don't have to change the model. Just set it up with the right signs. Disutility of loss, positive utility of delay. It's exactly the same model, multiply. And it fits the data. Some data doesn't fit. There is a subset of people that incur a debt that would rather pay it off right now than wait. I think they're in the minority, for sure. But carrying the, there's a nice a complement to that about just getting rid of the debt. Let's suppose I were to give you as your reward the ability to kiss your favorite movie star. Would you want it right now? Would you want to say, no, let me think about that. I want to anticipate and enjoy the thought for a week before. I have that data, okay? So sometimes there's a positive utility for delaying good things, and sometimes there's a negative utility for paying off debt, for debt right away. And the models don't do that, but those are realities of how people are different. You can set them up for that, for sure. So yeah, I'd like to think that, and the nice thing about debt, because portfolio plays a role in that, if you have a debt of $1,000 in the end of the semester, and time comes due, what are you going to spend your $1,000 on? What's in your portfolio? Only one thing. You got to pay the damn debt. You can't use it on other things. So you'll have a very narrow portfolio, I think, and steeper discount functions for losses. I haven't checked to see if that's true or not.
But that can also work in your favor, because if you have only one thing that you can lose, then that also equates for happiness, right?
No. I don't think so. I think what equates for happiness, I mean, 1,000 things equate for happiness, like that date you're going to have next week with your movie star. 1,000 things equate for happiness. One of them, I think, is a portfolio of desires that you might realize. I think one of the things that equates with sorrow is a very important thing in portfolio. Maybe the most important thing in the portfolio is to kiss that movie star, but you're not going to be able to do it, and that might leave you depressed. So this is not cut and dried, but having unattainable goals that are clearly unattainable could leave you pretty unhappy, even if they're goals. And so having realistic, even stretching the concept, a diversity of realistic goals. I'll be a painter if I can't be a painter. I've always liked music, I'll do that. If I can't do this, I'll do that. Having those, I think, makes for happiness. Hugo.
Yes. Now that you mentioned mental health, I was thinking people after therapy is more self-aware, so they could have a bigger portfolio after therapy, and also after therapy, people is more maybe people can appreciate things more than they did before. So, and in the discounting, the slope could decay slower with some things that before don't.
I think that's a great hypothesis. It's reasonable. Go ahead and do the experiment.
Okay.
Hi.
Hey,
Thank you for the talk. I really enjoyed it.
thank you.
And well, my question is about having contact with other stimuli in the environment. So, for example, well, first of all, if you want to have more things in your portfolio of desires, you need to have contact with those other things in the environment. But let's take an example and go to a restaurant, and I take the menu and I check, oh, there's a lot of things here. There's diversity. However, why would I take the risk of trying something new if I already know that if I eat, I don't know, lasagna, I would love it.
So you always eat pizza, is that right?
Yeah.
No, good question. I'm going to answer it in two parts. My wonderful host took me out to a nice restaurant the other day, and it had a very long menu. But I can only eat one meal. And I can imagine if I were in a restaurant that only had a couple things on it, and the meal that I would have chosen is there, I still sort of like the bigger menu, you know? The sense of more choices, even if I was going to get the same enchiladas or whatever. So I think restaurants often have larger menus than their kitchen can really support, because having a large menu is attractive. Why would you take a chance? Because you're a risk taker. You find some pleasure in thinking maybe this would be better, maybe it wouldn't be as good. If it's really bad, you'll tell the waiter to take it back. But, and you might or might not, or she might or might not. But why would you do it? That's something else. That's maybe that's inculcated young, the pleasure in taking chances of risky behavior. In a restaurant, it's not too risky. But if you are brought up with a parent that talks about rich portfolios, you may be more inclined to sample the environment more broadly than if you're brought up in a rigid family that there's only one right way to do things.
Okay, thank you.
Mm-hmm.
Hello there.
Hi.
As far as I can tell, your model is mostly based on human data.
Yes.
So I was thinking about maybe applying it to animal data. So I was thinking
Great.
about this type of experiments in which animals which are exposed to enriched environments are less prone to develop addictions. So maybe I was thinking if you think that animals who are in enriched environments are could maybe have shallower discounting curves.
You know, I do both animals and people, and I've done enriched environments, and I never put it all together. So that's a very nice insight. Animals in enriched environments with larger portfolio of achievable desires are less likely to be addictive. And by both counts, I guess I would predict that they would have shallower discount functions. So that's a great extrapolation. So do the research, send it to me, and I'll call it my own.
Okay.
No, I would never do that. But I do think that if you have animals around, it would be a fun thing to try to do. I don't know of any relevant data, and I think your idea is very good.
Thank you.
Yes. Okay. Well, you know, we could go on like this forever, but I think you should go on like this forever and keep thinking about these ideas and other ideas and have fun in extrapolating what might follow from this. And keep it in mind, and keep your portfolios of desires diverse and full. Thank you.
Thank you. Thank you very much. This is a certificate. Thank you very much. Well, thank you all for coming.